Hey guys, I'm Volin and welcome to day 6 of Advent of Code. 10 seconds left. I still have not catched up on enough sleep, but let's see how I'll be doing. So 4, 3, 2, 1, and let's start. The historians use their fancy device again, this time to whisk you all away to the North Pole prototype suit manufacturing lab in the year 1518. It turns out that having direct access to history is very convenient for a group of historians. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. You can start by making a map, your puzzle inputs, of the situation for your example. The map shows the current position of the guard with... Okay, so this is the guard here. To indicate the guard is currently facing up from the perspective of the map, and obstructions, crates, desk, alchemical reactors, etc. are shown as hashtags. Lab guards in 1518 follow a very strict patrol protocol, which involves repeatedly following these steps. If there is something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. Following the above protocol, the guard moves up several times until she reaches an obstacle. In this case, a pile of failed suit prototypes. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her new facing direction. Reaching another obstacle, a spool of several very long polymers, she turns right again and continues downwards. And this process continues for a while, but the guard eventually leaves the mapped area after walking past a tank of universal solvent. So she always goes right. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path, including the guard's starting position. The positions visited by the guard before leaving the area are marked with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? Okay, so this is a rather easy one, I think. First of all, we should get the example, so the test data. Let's create the data itself, .txt. How big will it be? Well, it's... Oh, I was going to say it's more reasonable than I thought, but it's still kind of large. What do we need to do? First of all, we need to find starting position. I will create a var position, vector to I. And let's start by setting that to 0. Date, well, let's call it map for once. And this will be an array of packed string arrays. Yeah, no, it's just a packed string array. Okay. Like I said, I have not been able to sleep very well. Having a baby in the house is kind of, yeah, busy. We don't know what position it will, like the arrow will be in, so we should check for all positions. We should also check for the direction, I guess. So var direction, 1 is up, 2 is right, and 3 is down. So we do need to check for all of them individually. If it contains this one, then we go up, but we also need to check where it is. So L. I feel like there's probably a better way of doing this. Okay, so that is for the starting position. I think we should probably make this into a separate function, just in case. Because the position and the directions are in here anyways, I think it's probably going to be fine. So the only thing that we need is a map, which is a packed string array. And then here we just change this to an A. So match direction, so we have... So if this is a hashtag that we print through, like this will return an error when we go out of the size of the map. So that's something we should also take in mind. I think let's return an integer. So 0 is three. One is obstacle, and two is exits. If it's a hashtag, oops, if it's a hashtag, we return 1, and if it's nothing, we return a 2. And then we go var L exits. For the L exits direction, let's use the exact same thing. So 0, 1, 2, 3. So this is an integer, and this is -1 for now. Whoops. If L exit direction is not 1, is not 0. And then here, -1. Position of up is +1. This is -1. And then over here it's +1. So this should be left, right, left, up, right, and down. Okay. And this should work, so we only need to figure out L direction. So if the Y position is 0 or aim up size, I think maybe we should do this, because we don't know if the length of the map is the same. So let's just take length, then we really are certain that we get the width of the map and not the height only. 3. Okay, and with that we get the exit direction. We need to get all the distinct, so all the places that he has, that the character has not been to yet. We could change everything to X position dot X plus equals minus equals 1. Over here this will become a plus, and then over here we have Y. So the position keeps updating. So if break, I think that's the only thing that we actually need to do. So if you run this, what should be the cannot find count on base int? If it's not as 2, then we break. But we don't even need to like check if it's like which direction it's going to. The only thing we need to do is a map position dot y, wait, a map dot position dot y position dot x. Wait, normally it's going up, so print test. Also, this does not really matter anymore. I'm probably overcomplicating this again. Like, I know I can definitely make this simpler. I can also definitely make this like better. Why? Why is it only printing 4? So now, why do we still go down? Why do we go down by 2? Because of these. Okay, 41. So this works. So if we now take the real data, yeah, let's run this. This should be the solution. That's correct. First of all, let's remove this print statement, because else I'll become crazy. Where is it? Oh, continue to part 2. While the historians begin working around the guards' patrol route, you borrow their fancy device and step outside the lab. For the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Returning after what seems like only a few seconds to the historians, they explain that the guards patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way that the guards will get stuck in a loop, making the rest of the lab safe to search. Oh no. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can be placed at a guard's starting position. Cannot be placed at a guard's starting position. The guard is there right now and won't notice. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations are 0 to mark the new obstruction, line to show a position where the guard moves up and down, and minus to show the position where the guard moves left to right, and plus to show the position where the guard moves both up and down and left and right. Option 1, put a printing press next to the guard's starting points. Option 2, put a stack of felt suit prototypes in the bottom right quadrant of the mapped area. Option 3, put a crate of chimney squeeze prototype fabric next to the standing desk in the bottom right quadrant. Option 4, put an alchemical retrib near the bottom left corner. Option 5, put the alchemical retrib a bit to the right instead. I'm not even going to try to pronounce those words. Option 6, put a tank of sovereign glue right next to the tank of universal solvent. It doesn't really matter what you choose to use as an obstacle, so long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes time paradoxes, and in this example there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? How would I even go about doing this? I think I will need to work with the plus and minus system to like really make certain that it's in the correct position. We need to keep the whole thing going, so when we go out, we need to check. Okay, this is kind of breaking my head right now, but let's see if there are any errors. Out of bounds, of course, out of bounds. The next step is the outside. We don't actually need to check anymore. So the only thing we need to do is this. So this is the only thing we need to do. Oh, wait, okay, I see what we're doing. We forget to check the X value. Oh, wait, I know what it's doing. I know what's happening, I know what's happening. I've been exactly working on this for an hour now. Let's be a little bit more creative. So we take the days, take day 6, and add child, rich text label. Okay, so we do get a map. I should probably change the color so it's black so we can actually see something. Normally it should find an obstacle around here. An obstacle, so that's correct. For some reason it finds an obstacle here. I was going to quickly calculate like how many times does it need to go over it. So wait, 1911. Okay, I think Godot just crashed. That's not the right answer. Your answer is too low. Curiously, it's the right answer for someone else. You might be logged into the wrong account or just unlucky. Okay, so some of them are taking longer, and I think the ones that are taking longer are because there are obstacles are detected. Wait, why do I test this with this data? I am an idiot. Let's use the test data first to see if that actually is correct. 6. Okay, so this should work. So, and again, now I need to let this run. So yeah, well, I'll be right back. I'll eat something. Okay. Let's see. So I got a number. But this is lower. It does not stop. That's not the right answer. Your answer is too low. Yeah, no, I'm stuck. He needs attention. Okay, so I think I'm on the correct path. I think I just need. I think I just need to increase my amount of total times that I go through it. How about I do it times L total steps? So just a minute, your baby. L total step. He's getting sleepy. Okay, and I run this one more time. Okay, what do you think? Will it work? No? This is taking a long time. You know what? I think this will be the first time, but I think I'm going to skip part 2 for now. This code needs way too much of like a redo to it. So I'll just skip this. I'll see if I can finish this by the time that I'm supposed to like upload this video, edit this video. If not, I'll just do it another day. Because right now we have a crying baby and I just cannot get through this. I cannot finish this today in like a reasonable manner. I've already spent 2 hours and 30 minutes on this, so yeah, I'm going to leave it at this for now. So yeah, quick thank you to all my Ko-fi supporters. Thank you very much for supporting me. And I guess I'll see you all or in the next part of this video in which I solve this issue and explain how I solved it, or you will just see the end screen. So what will it be? See you tomorrow if I didn't find a solution. Bye bye. I did it. I did it. He's quiet. He's quiet. Finally! I'll be able to concentrate this time. I'll try one more time. Let's see. I have a lot of fixing to do, I think. I didn't want to give up and I didn't give up. So I got the solution. I think I'm peaking my audio a little bit by going too close to my microphone. I basically had to redo everything. Like the entire code, I had to redo everything, even part 1, so I could do part 2 more correctly. It was a pain. It really was not fun. It's now 8:30, about 8:40, and I finally finished it. That's the right answer. You are 1 gold star closer to finding the chief historian. I kept getting different results. I don't know what exactly I was doing wrong, but I kept getting different results every single time. But it's working. So don't watch these print statements. Part 1, 5444, and part 2, 1946. So the way that I was able to solve it, first let's go over the code quickly. So part 1, I get my path, I get my map, I set my direction, position, and whilst through we go over everything. If we reach the end, we break, and then we count the positions on the map. For counting the positions, we are counting the lines and the plus. I changed it to the example because I thought it would probably make a little bit more sense. I got this draw map function here, so it will just take the map, change the specific like character to whatever the path is. If you went already over it, it will become a plus. Our step function, before it was check step, now it's step. So first we draw the map. True is okay, false is exit. First we check, can we keep walking? If there is something in the way, we don't walk. Then we change direction if needed. And then we check if we are, and the next block is at the exit or not. If it's not at the exit, we return true, else we draw the map, and false. If you don't draw the map, we have 5443. Okay, so that part is done. To get the position, I just, search for the character. And something that you may notice if you were paying close attention, I'm using vectors now. That's right, my direction is a vector and my position is a vector because I realized vector 2i has an up, down, left, right like system. So I started using that instead. For part 2, I took the map, I took a copy of that map and just the total amount. I reset the positions, but I saved the main position because the main position normally also gets changed in code in the step function. So I just save the position so we can keep reusing the position without having to check like the new empty copy, I guess. We first fill in the map, so we have all the the whole paths, like all the lines of where everything goes. And then we check the X and the Y, but we make certain that it's not on a place where there is a hat, well, the up arrow, hashtag, or the dot, because our path is already filled in and we can only place 1 obstacle, so it has to be on the path. So if it's not on the path, we continue, and else we copy the map, because this map will have been overridden by the step function. Plus we also add the hashtag, like the new obstacle, and we also refresh past, because past, every single value that we go over, every single position that we go over, with the direction, we are saving. We are appending to L past. And if we go to the next part and there is already a position on there, like we already got that to the L past array, then we do L total plus 1 and we break and we go to the next one. This takes a long time to run. Like even on my PC took, well, you know, my PC is like kind of very old, outdated. So yeah, it took around like 4 or 5 minutes. So yeah, but it works. I'm glad I didn't give up. I don't like giving up, and I will probably have stayed awake the entire night trying to figure out why is my code not working. But yeah, it's over. Today is over. Day 6 is over. And a big thanks to my Ko-fi supporters, as always. I really appreciate you guys. And I'll see you all in day 7 tomorrow. Yay, daily videos. It's almost 8:50 and I still need to edit this. And I have, again, over 3 hours of footage. Yeah. Well, see you all tomorrow. Bye-bye. Also, yes, I already washed myself and I'm in my pajamas, so I don't care. Bye-bye.